So far we have completed the first topic, sample space and events. Now we will discuss the second topic, the second subunit, that is probability. So before we can start with what is actually meant by probability, it is necessary to understand the concept of equally likely events. See, the name itself suggests what this definition means. Equally likely means, suppose there are two events A and B. Both these events are said to be equally likely if no one is given preference to another. That means both these events are equally important. Not A is important rather than B, or we are not assigning importance to B than A. Suppose if these conditions are valid, then we can say that these two events are equally likely events. The outcomes of a random experiment are said to be equally likely if, after taking into consideration all relevant evidence, none of them can be expected in preference to another. Suppose there is an examination, and for that examination the number of students registered are supposed to be 50. Then these 50 students are assigning equally likely, means the same question paper should be given to all these 50 students. Out of these 50 students, some may get passed in an examination and some may fail in an examination. But the question paper is same, means they are given an equally likely importance. So equally likely events are the events that have same theoretical probability of occurring. So whenever we are talking about equally likely events, we are talking about equiprobable events. Equiprobable means those the probability remains the same for all these events. Now take an example. In a toss of a coin, getting heads and tails are equally likely events. That means the probability of getting head is 1 by 2. At the same time, the probability of getting tails is also 1 by 2. That means the probability is same. These two events, head and tail, is said to be equally likely. Take one more example. In drawing a card from a pack of cards, there are 52 equally likely cards. That means the total number of cards in a pack of cards are 52. Therefore, the probability of getting any card out of these 52 cards is 1 divided by 52. So that means this is equally likely. All these cards are equally likely cards. So take one more example. So also getting red card and getting black card are equally likely events. That means there are 52 cards, but out of these 52 cards, there are 26 cards which are red cards, and there are 26 cards which are black cards. So therefore, probability of getting a red card is same as probability of getting a black card. Therefore, its probability is 26 divided by 52, which remains the same for red card as well as black card. Therefore, these two events are said to be equally likely events. Once we understand the definition of equally likely events, then it is easy to understand what is the concept of probability. Friends, probability is nothing but the possibility, the chance. Probability is nothing but the things which were happening in future. But whenever we are talking about probability, we are normally talking about the chance of happening or non-happening of an event. So what is the probability that today there will be a rain? What is the probability that in the forthcoming semester examination I will be getting more than 70% of marks? Event is happening in future, and we are interested in knowing what is the chance of happening of a particular event. In probability, we not only we are talking about happening of an event, we are also talking about the non-happening of an event. So probability is the chance of happening or non-happening of an event. And in the theory of probability, that will gives us a quantitative measure of the element of uncertainty in an experiment. Friends, whenever there is a chance, there is a possibility, we are normally talking about the future tense, and future is always uncertain. but one may be interested in knowing, in calculating, in quantifying the event which is uncertain in future. Therefore, the theory of probability gives a quantitative measure of the element of uncertainty in an experiment, and also it enables us to take decision under conditions of uncertainty with a calculated risk. Suppose if we are interested in knowing what would be my performance in the forthcoming semester examination, we can find out this under certain conditions. What is, how many times I have studied, how many times I have learned all the concept in the particular subject. So that means depends upon this, we can find out how my performance will be in the forthcoming semester examinations. So normally probability, finding the probability means quantifying this the element of uncertainty with a calculated risk. So there are three types of probability. The first is classical or mathematical or a priori. This is also called as Laplacian definition of probability, because this is given by the mathematician Laplace. The second type of probability is axiomatic definition of probability, and the third type of probability is a statistical definition of probability. So we are interested in classical and axiomatic definition of probability. We are not or least interested in what is the statistical definition of probability. So what is classical or mathematical or Laplacian definition of probability? So if a random experiment results into any one of n mutually exclusive and equally likely outcomes, see, these two are very important, because these events must be mutually exclusive. Mutually exclusive means there should not be any common point in these events, and also these are equally likely. Equally likely means every event has an equal opportunity to become the part of the sample space, and also their probability remains the same. If these two conditions, these two important conditions were held, then we can say that out of these n, total number of outcomes, and out of these n, m are favorable to an event A. It is given by the definition of probability, and it is denoted by P of A. P of A is the probability of A. And what is probability of A? So that is how many cases are favorable to A. It should be divided by the total exhaustive cases in omega. So that means n of A means what? N of A is the number of cases favorable to A for the particular event, and this n of omega is the total number of members in the sample space. And suppose m cases, out of this n, so there are n cases, and out of these n cases, m cases are favorable to A, means probability of A is what? M divided by n. So that is the ratio of favorable cases to the exhaustive cases. That is the simple classical definition of probability, and this definition is given by Laplace. What are the important remarks in this classical definition? So that means this m should lies between 0 and n. N is a finite, therefore the probability of A always lies between 0 and 1. So it is very important that probability of A is always lies between 0 and 1. Probability of A is 1 if A is a sure event, and probability of A is 0 if A is an impossible event. Sure event means suppose all the cases favorable are the total number of cases, and impossible means no case is favorable out of these n cases. So that is 0 divided by n, so that is equal to 0. And if all the cases are favorable, so that means n divided by n, so that is P of A is equal to 1. So this definition does not require actual performance of an experiment. So there is no need to actual performance of an experiment. We can intuitively find out the total number of outcomes, and out of these outcomes how many cases are favorable, and accordingly we can estimate what should be the probability of this event. Then suppose if this is my sample space, this sample space consists of n events. Out of these n events, m cases are favorable to A, therefore my probability of A is equal to m divided by n. So this clearly means there are n minus m cases which are not favorable to A. So therefore probability of A complement is number of case favorable are n minus m. and the total number of cases are n. If we divide n minus m by n, so that will gives us 1 minus p of a. So that means n divided by n minus m divided by n. So n divided by n is 1, m divided by n is p of a. So p of a complement is 1 minus p of a. Therefore, p of a plus p of a complement equal to 1. So we will stop here, and we will take some examples related to probability in the next session. Thank you.